Okay, good morning. So let us solve the problems of the homework. So this first problem, how many 5-element subsets of this set A, 1, 2, 3 up to 10 do contain at least 3 odd numbers? Okay, so the problem is this. We have a set A, 1, 2, 3 up to 10. Okay, so let us for concreteness write all the elements. So 3, 4, 5, 6, 7, 8, 9, 10. We want to know how many 3-element subsets are there so that each one of those subsets has at least 3 odd numbers in it. Okay? If I just ask you how many 3-element subsets are there, the answer is very simple. So what's the answer? If I just ask you how many 3-element subsets are there, it means that you want to choose 3 elements from these 10. And you know that in a subset, order does not matter, so it becomes a combination problem, not a permutation problem. So the answer will be 10 choose 3, if there is no constraint there. But now you have to respect that you have to choose at least 3 odd numbers. And then interpretation of at least is also simple. It means that you exactly choose 3 odd numbers, or you choose exactly 4 odd numbers. Or you choose exactly 5 odd numbers. Yes, because you have to choose 5. Oh, sorry, made a mistake. We are supposed to find 5-element subsets. If there is no constraint, it will be 10 choose 5. Yes. Now there are some constraints, so I will count the number of my choices so that I have exactly 3 odd numbers there. This is one scenario. Or I can have exactly 4 odd numbers, or I can have exactly 5 odd numbers. Yes, if it is possible. And then I add them up. These are different scenarios. If I want to know the total number, I just need to add them up. Okay, so in how many subsets, 5-element subsets, there are exactly 3 odd numbers? So let us think in this way. I ask you to write a 5-element subset in which 3 of them are odd. So how do you do that? Yes? For which case? Yes, you say that I have 5 odd numbers in principle here. Yes? I want to have exactly 3 of them chosen. So it means that out of these 5, I choose 3. But the task is not accomplished yet, because so far how many elements I have chosen? I have chosen 3, but in the problem they are asking about 5-element subsets. Okay, so this means that I have to choose 2 more. But these 2 more should be chosen from where? You might say that, okay, this is a common mistake. Sometimes people say that, okay, I have used 3 of them, so 7 of them are still left. Then they will choose 2 out of 7. This is not the correct way, because if you choose 2 out of 7, it means that you have still a chance to choose another odd number. But in this scenario, I am counting the number of 5-element subsets with exactly 3 odd numbers. So this means that when I choose 3 out of 5, I made my mind. I only want to have 3 odd numbers. The rest should be even, even if they are not used here. So this means that the last 2 elements should be chosen from 5 again. 5 because of even numbers are also 5. So this is the first one. This is the number of 5-element subsets, so that each one of them contains exactly 3 odd numbers. Is that right? Or 5-element subsets with exactly 4 odd numbers. Very simple. So this time, out of 5 odd numbers, I have to choose 4 of them. 1 more is left to me, but this one should be chosen from even numbers, because if I choose this from the rest, I might increase the number of odd numbers, which I don't want. So this I have to choose 1 out of 5. 5 choose 1. Yes? And finally, I choose all of them to be odd. If you want, you can write 0 from 5, but that is also the same as 1. And then this is the number. I have this number in my memory, this happens a lot. So this is 10. But tell me, if this is 10, I have given you access to GeoGebra as well, so you can use it. But here 10, if this number is 10, I guarantee that for you. I have it in my memory. What is this number? We had a formula. This I wanted to know. N choose R and N choose N minus R are always the same. So if the numbers on the bottom, they add up to the number on top, these two binomial coefficients are equal. So if 5 choose 3 is given to be 10, then you need immediately understand this one is also 10. Why? Because these numbers add up to the top number. So if this is 10, I give you this is 10, so that one also becomes 10. But what about this one? Which one is simpler to calculate? Here I have 5 things, I want to choose one of them. In how many ways I can choose 1 out of 5? 5. Yeah, so you don't need to calculate. But according to the same rule, if this one you could calculate in your head is 5, what will be this number again? 5, because 4 and 1 add up to 5. So then if this is 5, that is also 5. And what is this number? I have 5 elements, I want to choose 5 of them. In how many ways I can do that? Of course, you can write a formula, but I want you to be able to go back and forth between formulas and analytic understanding, okay? So this is what? 1. And then this becomes 126. So that's the answer to the first. So 126 is the option that we have to choose here. Yes?
Why can't you just from the beginning do that 5 choose 3 and then multiplied by 7 choose 3?
No, I told you that this is not working. Because what you are counting here, you are counting 5 choose 3. That was exactly the common mistake I told you. So you say that I choose 3 out of 5. Yes? This means that this is the number of 3 choices out of 5 choices. But if you say that, okay, so far I have chosen 3 odd numbers, how many of them are left? 7. And then I want to choose 2 out of those 7, the way that you do it, this means what? So what you are counting here?
I'm counting it has at least 3 odd numbers.
It has 3 odd numbers, but even more. Yes? Because when you say 3 out of 5, it means out of these underlined numbers, you have chosen 3 of them. Which one, for example? It doesn't matter. This one, and this. And then you say that 7 of them are left. I choose 2 out of them. But one of those cases you are considering here is, am I allowed to, according to your way of counting, am I allowed to choose 9 here?
Yes.
Yes, but that is violating my rule, yes? Because 3 odd numbers are there, and you are giving the chance of 9 be chosen again in this field. And then totally you will have 4 odd numbers.
But in that because it asks to have at least 3 odd numbers.
Okay, so you are right, at least. But let us see why it doesn't work in that way. Yes?
Repetition isn't allowed, right?
No, repetition is not allowed. That is a set. In the set, you are not allowed to repeat an element. Yes, that is clear. Okay, so let us see why. That's a good question. Okay. First of all, my guess is that this number is probably bigger than this number. Yes, because I'm sure that we are counting something more than once. Okay. So let us see. That is a good question. So here, if I choose 3 out of 5, let us say that I have, okay, I can say something now. So for example, I have 1, 3, and 5 chosen here, okay? And then, for example, what do you choose here? 2 out of 7. For example, let me write, so you are not on, okay, that is eliminated. Now I choose, for example, 2, and then, for example, 7. Yes? This is one of the, let me think, because that is not a very simple question to answer. So 1, 3, 5, 2, 7 is one of the choices you count in the way that you are counting, or you agree with me or not? Because you are saying that in the first one, I choose 3 of them, 1, 3, and 5, and here I choose 2 out of the remaining 7. Again, you choose these 2, yes? But I want you to understand that by the way, there is no order because that is a subset. Okay, but now, do you agree that this is also counted again? For example, 3. No, because when you are saying that I am choosing 3 out of 5, you might choose 1, 3, and 5, yes, in the first stage. After you are done, you choose 2 and 7 in the second stage. Yes? But is it possible to choose 1, 7, and 5 in the first stage and 2 and 3 in the second stage? So you are counting this again. But this, if you are counting ordered ones, you are right. This is different order from that one. But is this one and this one different subsets? No. They are the same subsets, but you give the chance of, for example, this one to be counted again. That is why my guess is that if you calculate this number will be bigger than that number, because you are counting the same item more than once, but you are supposed to count every item exactly once. Is that clear first? Yes? Yeah, because this is one of the options that you have for this way of counting. That is also another option that you will count, but these two are the same substance. Yes?
But look, doesn't this work? Like, this doesn't work because you have 7, choose 2. Because 7, you have only 5 odd numbers.
Yes?
How does it come that you put 7 there?
No, I'm not putting 7.
Yes,
He's
I know,
putting 7.
but
No, the logic is not that bad because he's saying that, okay, we want to have at least 3 odd numbers. So let us choose 3 of them, and then let us choose 2 out of the 7 leftovers. If these 2 are chosen from odd numbers, so from even numbers, then I have exactly 3 odd numbers. But this is still, if this is chosen from the odd numbers, then I will have more than 3. So it means at least 3. So the logic is not completely wrong, but I wanted to know, it was more technical to understand why that method does not work. Do you understand what I'm saying? So that is why, so this was a very good question, to be honest, because that is extremely important. Whenever I want to use the sum principle, do you remember, I always tell you, be careful that these groups don't have any overlap. Because if there are some overlaps between these things, you are counting the same item more than once. And this violates the sum rule. So probably it's exactly clear why this is not correct. Even though it was, when you said that, I was doubting that might be this should also be correct. But that is not correct. Do you feel it or not?
Yes.
Yeah, okay. So that was a good question, thank you. So let us go to the next problem. A group consists of 9 husband-wife couples. 10 people are randomly selected. What is the probability that exactly 3 pairs of the selected people form husband-wife pairs? Round your answer to 2 decimal places. Of course, here we need GeoGebra. For this problem, I gave you access to GeoGebra so that you can calculate this number up to the end. Okay, but I would say that this is also a little bit tricky question. I don't know how many I didn't have time because I had made some mistakes in in writing the text. I fixed it later. So how should I solve the problem here? Is the problem clear? So how many husbands, wife we have? 9. Yeah, so let us say man, woman, number 1, man 2, woman 2, man 3, woman 3, up to man 8, 9, woman 9. So let us say that we have 9 couples, husband, wife pairs. Yes? Yes? And then how many people I want to choose? I want to choose 10 people. Okay, whenever you want to calculate the probability, what is the probability? Whenever you have probability, you have a fraction. In the denominator, you have to put the number of all possibilities. And in the numerator, you have to put the number of things, the number of items that you are interested in or you desire. And my recommendation is that whenever it comes to probability, calculate the denominator because it is much simpler first. Okay, at least you can solve 1% of the problem, or I don't know how many percentage, but you can solve one part of the problem. So can you tell me how many options I have available? What? No, I am choosing 10 people out of 18 people. How many choices I have? Yes? So what should I write for the denominator? In total, how many people are there? 18. I want to choose 9 of them. Yes? No, 10 of them. Okay. So it means that in how many ways I can choose 10 people out of 19 people, 18 people? What is that? 18 choose. So that is as simple as that. Okay, so this is the total number of possibilities that I can choose 10 people out of 18 people. But do you agree that, for example, I might have chosen all the men, okay, and one W1. Then how many husband-wife pairs I have? Only one. Because these two will make a pair, the others are not a pair. But this is not what problem wants. I want to choose them in a way that there are exactly 3 couples, 3 pairs, yes, 3 pairs. It is written in the problem. Okay, so how many ways I can do that? Let me pause recording and give you a little bit of time to think about the problem yourself. In principle, you should think about the problems before coming to this lesson, but because I saw that not many of you solved the problems. I want to pause the video and give you the time to think. Okay, so do you have any opinion? So in the numerator, what I am trying to do, I am trying to choose 10 people, but I want to choose them in a way that I have exactly 3 pairs of couples in my choice. Okay, so how do you think? Yes?
Can you say 10 to 6?
6 from?
10.
So just this one?
Yes.
Okay, so this means that how are you respecting the condition now? Because when you say I choose 6 out of 10, first of all, where is your 10? What do you mean by 10?
10 people you chose.
No, 10 I choose.
Yes.
But this means that you are choosing 6 out of 10 people.
Yes.
So why? so yes, you have to defend yourself.
No, because
You are choosing 6 out of 10 people.
yes,
And you are saying that this is the number of choices that I have to have exactly 3 couple pairs among my 10 people that I have chosen.
Yes, because every 2 you have 1 pair, and you have 3 pairs. So you get
No, you want to choose it. So if you choose 10 people randomly, there is no guarantee that you are choosing exactly what you want. You need to count the number of possibilities that in all the choices that I have, and I have written here, I have exactly 3 pairs of couples among the people I have chosen. And to be honest, I don't understand why this number is taking care of that constraint. Because what I see here is that I am choosing 6 people out of 10 people.
So because
This is the number of ways that I can choose 6 people out of 10 people. But then you are saying that if you do that, It is exactly the number of ways that you can choose 10 people out of 18 people in which there are exactly 3 pairs of couples.
Okay, so you still have 18 people.
You still have, you have 18 people. No, forget about the denominator.
Okay.
Okay, denominator, that this is two problems. One, the total number of possible ways that I can choose 10 out of 18 people. That's it. Forget about it.
Okay.
Now, think about a different problem. Now you want to choose 10 people, but you have one constraint. Here you just want to choose 10 people without any constraints out of 18 people. That's why I'm saying, that's my recommendation, to do the denominator first. At least one part of the problem is solved and you are a little bit relaxed. Okay? But when you go to the numerator, this is a new problem again. Don't confuse it with this one. But the problem is still, I am supposed to choose how many people? It's still 10 people I'm choosing, yes? But this time, I want to choose them in a way that after the task is accomplished, I see exactly 3 pairs of couples among the people that I have chosen. This is nothing to do with this, yes? Okay, any such, yes?
I was thinking 9 choose 3.
9 choose 3, okay. So that makes at least a little bit of sense to me. I think that's good. 9 choose 3. What is the logic behind that?
So there's 9 pairs, and you want to have 3 pairs, exactly 3 pairs in your choice.
That's it?
And that's what I was thinking.
But no, I mean, is it finished?
No, it's not finished.
Okay, that's what I'm saying, because I want you to understand, here it is not finished. Because what you are saying is that I have 9 pairs, and I want to have three of these pairs among my choices. If you just stop here, how many people you have chosen so far? 6. Yes? Because you have chosen 3 pairs. But the task is not accomplished because I am supposed to choose how many people? 10. So you need to say something about the rest. Yes. Okay, please continue.
And then you can multiply by 6, choose 4.
Very good, very good. So what is the logic of this one? You say that I chose 3 pairs out of 9. So how many people you have chosen? I have chosen 6 people. Okay. And then you are saying that I choose 4 out of 6. What is the logic behind that?
So there's 6 remaining couples, and then to make sure that there are no husband and wife pairs again, you choose out of the 6 couples you have left, you choose 4 couples, and then you multiply by 2 to the power 4. So you choose.
Very good, very good. Yes, that's the answer. Yes, that's the answer. I think so that logic is clear, because what you are doing, you say stage 1, choosing my 3 pairs of couples. Yes? So you break this problem, so still your problem is what? I want to choose 10 people out of these 18 people, so that there is exactly 3 couple inside my choices. So what I do, I would say that let us do like that. I don't want to form a headache for myself. Let me choose my 3 couples and put them aside. So what you are doing, you have 9 choices, you have 9 couples, you choose 3 of them in any way. For example, let us choose these 3. And now these groups, I put them aside. So I have exactly the 3 couples that I need. Yes? So that one is for this one. But the stage 2, so that was a stage 1. The stage 2, so how many people are now, how many other couples, how many other pairs are left? 6. Okay? What you do, you need to, how many other people you need? So you have chosen 6 people here, yes? And then you go to these couples and choose 4 of them. Okay, out of those 4, you need to choose 1 person from each group. Is that right? Because you are not allowed to form any new pair. Because if you form a new pair, I already have more than 3 pairs. I want to have only those pairs. So among the left ones, so how many more couples you see here? 6. Yes? Okay? And then how many person I need? How many persons I need to complete my choice? 4 more. Because when I choose 3 people, 3 pairs, I have already 6 people chosen. But I want to make it 10. So I need how many more people? 4. Okay? But I have to be careful. I cannot say I choose how many people are left. 12 people are left. I cannot say I choose 4 out of the leftovers. Do you agree this is not working? Because if you do that, then it means that you might choose these people together again. But then what happens? You already have your 3 couples. If you choose these 2, you will have 4 couples. But you don't want to have that. You want to have exactly 3 couples. Understandable?
But why can that happen when you choose 4 out of 6?
No. So I think you're a little bit confused. Okay, so let me just explain again. So what he is saying that I have 9 pairs. I need 3 pairs. I think everyone agrees with that. Yes? This is the truth. But how many people I have to choose in principle, according to the problem? 10. This means that how many people are chosen now? This is 3 pairs. So how many people have been chosen? 6 of them. So in order to reach to this 10, I need how many more? 4. Okay? If I ask you how many people are left, you say that 3 pairs are chosen, so 6 people are gone, so 12 people are left. A common mistake is to write, I choose these 4 people from the 12 people left. Okay? This is one logic, but that is not correct because when you write I choose 4 out of 12, can I choose these 2 together and these 2 together when I write like this? Because this tells you choose 4 out of the 12 leftovers, yes? One possibility is to choose this one, this one, this one, and that one. And then if I put these people back next to them, then how many pairs I will have?
5.
I will have 5. But the problem wants you to have exactly 3 pairs. So this means that this is not working. I have to do it in a way that guarantees that no new pair is added to my old group. So how can I take care of it? The way he told us is to go here. You need 4 more people. Okay? What he does, he counted the number of ways that I can choose 4 groups out of the remaining groups. So I would say that 6, 4. So this means that I take my marker, for example, I mark this one, the last one, and for example, 1 to the last. So I marked my groups. Okay, so this means that these 4 people should be chosen from these groups, but not 2 of them from the same group. So this means that from this one, I choose 1 person, either the man or the woman. I go to the next, I choose 1 person only, either the man or the woman, and the same thing here. Okay? So this means for this one, I have 2 options. I can choose either the man or the woman. Here I will have 2 options, either the man or the woman. Here I will have 2 options. Here I have 2 options. And that is why I have to multiply it by 2 to the power 4. So this is the number of ways that I can do that. Yes?
But why can that happen that you choose again another couple? When you
No, this way of doing it is not possible. Because these 3 are these. So let me write everything down. I am lazy to write it, but let me write it. By the way, I am not saying this is the only way. This is the way I also thought about the problem, okay? If you come up with a new idea, we can sit down and think about it, or we can discuss it here. But let me write it. I'm just describing what Sepri mentioned, and I think it is correct, okay? Because that's the way that I was also thinking. So here I have this scenario. Do you agree? Okay. So what I will do by this, I choose 3 out of 9 groups. So let us say that I have chosen this one, and I have chosen that one, and I have chosen this one. Okay? I can choose in different ways. In how many ways I can choose 3 couples out of 9 couples? This is the number. Okay? So far, what do I have? I have this one. Now let us say that the first stage of the task is accomplished. It means that I determined which pairs I want to choose. These are the pairs I want to choose. But so far, and I know that I want to choose 10 people. So far, how many people I have chosen? 1, 2, 3, 4, 5, 6. So how many more people I need to choose to accomplish the task? 10. So I 4, so that it becomes 10. Okay? So these 4 people, if I write, one option is to think to write like this. Okay? I want you to understand, first of all, this is not the correct way of doing things. Because when you write out how many people are left, if you count them, there are 12 people left. And when you say choose 4 out of 12, you might choose this one, this one, this one, and that one. Yes? If you just write 4 out of 12. Okay? Then it means that you will have 2 more new couples added to your choices. So it means that I have 5 couples violating the condition of the problem because I'm supposed to choose exactly 3 couples. Okay? So at least you understand this is not the correct way. Okay? So what we are doing here, it's me and Sabri, we are choosing, so how many pairs are left? 6 pairs. But how many people I need? 4. So what we do, we choose 4 out of 6. What does this mean? It means that I decide to have this group, I need 4 markers. This group, and that group, for example. This is what I am doing. Think what I'm thinking, don't resist. I am explaining how I am thinking. Okay, so you cannot resist at this moment. But I see in your face you are resisting now. Okay? I am taking my pen, I am marking these groups. Yes? And what I want to do, this is the number of ways that I can mark the groups. Yes? No resistance, that is clear. Okay? But now what I want to do, I want to go to this group and I want to choose either this one or that one. Okay? So in how many ways I can pick up a person from this group and respecting the condition? If I don't want to respect the condition, I have 4 possibilities. Choose this one and that one together. Choose this one but not that one. Don't choose this one but choose this one, and don't choose anyone. How many options are there? There are 4. But I'm not saying 4. I'm only interested in 2 cases. The cases that I choose the man, not the woman. The cases that I don't choose the man, but the woman. So how many ways I can determine my mind for this marked group? 2 ways. Yes? This 2 means either I choose the man, but not the woman, and bring it here into my group. I'm not violating anything now. Yes? Or I choose the other way around. Still, I'm not violating anything. Okay? So, and then what do I do here? For this marked group, I have also 2 options available for the same reason. And then this one too, and that one too. What I'm saying is that this is choosing 10 people in total, as I need, yes? And I am respecting that there are exactly 3 couples, but not more. So this should work.
Yes.
Okay? But if you have any other suggestions, we can sit down and discuss about it until the lesson is finished.
No, but
Yes.
just a question.
Yeah.
When you say 6 choose 4,
Yes?
when by the 6 you mean the six pairs that are left.
Yes.
And when you say 4, then you mean you have to choose 4 people.
No, I am choosing 4 groups out of 6 groups.
Okay.
Yes? So this is 9. This 9 is the total number of pairs. I am choosing 3 pairs. Okay? Here 6 is the number of pairs left. Out of the pairs, I am marking on top of 4 pairs. And then if the pairs are clear, I go inside the pairs, choose exactly 1 person from each group. Not, I have to take care, I'm not allowed to choose both of them. In this way, I am taking this into consideration. Yes? And now if I wanted the probability, I have to divide this number by that number. Yes? So that will be the probability. Okay, so let us go back to GeoGebra to see how I can do it in GeoGebra.
So what should I do? I open a pair of brackets and I go and divide by. Okay, so let us just do the calculation in the numerator. Do you remember what was the NCR? I think yes. NCR. What is the first one? 9, comma 3. Oh, it should be pair of brackets. Yes. Okay, 9 3, and then I go NCR again. I choose this one, 6 4, and then 2 to power 4, which is just 16, and then I divide by and choose R. What are the numbers? 18 and 10. That is the exact number, and I want to choose it up to how many decimal points? 2 decimal points. That is already set up here, so I put this approximation 0. I don't understand that. Might be I have to put a dot here. Are these numbers correct? I don't understand. Why 0? Okay, let me type it here. GeoGebra is crazy sometimes. But 56 is also... Okay, let me just do that. Divided by 12, it is... Yes, it is 0. Because up to 2 decimal points. So might be my answer is wrong. Oh, because I use GeoGebra to calculate that number, but this is the correct number. So let me increase the number of decimal places. The reason GeoGebra provides 0, probably it means by 2 decimal places it is 0. Did I type these things correctly?
It should be 20,000, I believe. On top.
This is the number. That is the reason GeoGebra was telling us 0, because up to 2 decimal points. But let me refresh this, because GeoGebra sometimes make crazy things, but let me do that. Did you also get the same numbers in the options when you did it, Sebri?
Yeah, I got it.
Okay, so might be that is very strange. So let me do it again. N, choose R, and then what do? I put the numbers 9 and 3, yes? 9, comma 3, and then I go and multiply. Oh, okay, I remember what I did mistake. I put a point there. Okay, so, yeah, sorry. So what I will write NCR again. So what is the numbers? What are the numbers here this time? 6 and 4. Yes, okay. And then I multiply this by 16. So this is the number. And then I divide this by that number. NCR. You don't need brackets because this is multiplication and division only. 18 and then comma 10. Yes? And this is the number. This is more reasonable. 46. Yeah. So be careful. So yeah, sometimes GeoGebra makes... I think I made a mistake. Instead of putting a star as the dot for the product, I put decimal point there. Okay, that's the answer anyway. Any questions? Okay. So let us go to the next problem. So we have to choose this option here. The next problem is there are 5 points on each side of the triangle ABC, excluding vertices, making a total of 15 points. Using these 15 points, how many triangles can be constructed? Okay, so this is an easier problem, I think. We can think a little bit about it. So what do we have? I have any triangle. Let us draw one triangle. And there are 5 points on each side of the triangle, excluding the vertices themselves. So it means that here I have 1, 2, 3, 4, and 5 points. Here I also have 1, 2, 3, 4, 5 points. And then I have 5 more points here. Okay? And then I want to use these points to construct new triangles. and I want to ask you how many triangles I can construct. That's the question. So how should I answer the question?
Should we
No, you can answer, yes.
So
You give me your strategy, yes?
I believe there's two ways to make a triangle, and it's either you choose 1 point from each side,
Yes?
or you choose 2 from one side, and then the other point.
One from the other side. These are the only options that comes to mind, yes? Either you decide 1 point from this, 1 point from that, and I don't know, 1 point from this, and connect them. This makes you a triangle, yes? But this is not the only option. But let us count these type of triangles first. If I want to count these number of triangles, I need to choose 1 point out of these 5. I need to choose 1 point out of these 5, and I choose 1 point out of these 5. Okay? And then they have to be one after the other. So I choose 1 point out of 5 for this, or I can just simply write 5. It doesn't matter. In which way you want, it doesn't matter. This is the number of ways of constructing these type of triangles with exactly one vertex on every side. But I hope that you agree this is not the only option that I have. For example, I can choose this one and that one and this one. This is also a triangle. But this triangle is not counted before, because now I have chosen 2 from this and 1 from here. In how many ways I can construct these types of triangles for which 2 corners are being chosen from one side and 1 corner from another. Okay, how do you think about the problem? So first of all, you know that from one of these sides you are supposed to choose 2 points. So there is 3 options for the side you want to do that. Yes. So how many sides are there? I have 3 sides. Okay. So this 3 that I'm writing here is the number of ways that I can choose a side from which I want to choose 2 points. I can choose 2 points from this side, one option. I can choose 2 points from this side, one option. I can choose 2 points from this side, another option. So this 3 that I have written there is representing in how many ways I can choose a side from which I want to choose 2 points. Okay? And now I need one side to choose so that I can choose 1 point from it. So how many sides are left for me? One of them is chosen from which I am supposed to choose 2. One side, 2 more sides are left for me. So it means that I have a choice of 2. I have to make, so here I have chosen this. In principle, I had 3 options to choose this. I chose this. And I had 2 options to choose the side with 1 vertex. I chose this. I have 2 options. So far, I have determined in how many ways I can decide about the sides. From 1, I choose 2. From 1, I choose 1. Okay? Now, the sides are settled. Let us say that this side is chosen for 2 points. This side is chosen for 1 point. Now, I need to choose my points from here. So how many points I need to choose? 2. Out of how many? 5. Yes? Order does not matter. Yes? Because if I change these 2 points, it gives you still the same triangle. So that's not a permutation problem, that's a combination problem. And then, what should I multiply? I need to choose my 1 vertex from here. So I have 5. I want to choose 1. So if I calculate that, it becomes 6 times this number I have in my memory. This number is 5. So what is that? 300. Yes? And then that one is what? 5 times 5 times 5, which is 120. So what is the total number of triangles that I can construct? The sum of these 2 numbers. So it is 125 plus 300. So the answer will be 420.
Is that right?
So I think I would say more or less this is the only logic. I'm not sure if you come up with another logic, but if you understand that one, I think that's okay. Is there any question to understand? Yes?
Why is it 3 times 2?
So again, I am counting these type of triangles. These type of triangles are those triangles so that two vertices are on one side, one vertex is on the other side. Yes? So it means that if I want to count the number of these triangles, first of all, I decide about the side from which I want to choose 2 points. Yes? How many sides are there? 3. When I want to choose the side, I have 3 options. I can choose either this side to pick 2 points from, I can choose this side to pick 2 points from, or I can choose this side to pick 2 points from. So that 3 that you see is here is the number of choices that I have for the side from which I want to pick 2 points. Is that right? Okay, so this means that now I have to decide about the side from which I want to choose 1 point. Okay, this side is already occupied because I want to choose 2 points from it. But I want to choose a side from which I want to pick 1 point. There are 2 sides left. Either I can choose this one or I can choose this one. Because, for example, you can also consider this triangle. Yes? So this means that I have to choose the side from which I want to pick 1 vertex. So I have 2 more options for this. And then when the sides are settled, I know that from this side 2 points should be chosen, and from that side 1 point should be chosen if I multiply. Yes?
Any questions? Okay, so that was also not a bad problem. I mean, this was a simple problem, yes? It was not tricky. I would expect you, in principle, you should be able to solve this problem. Okay, so this option we choose, yes? And then we go to the next problem. This is also a good problem, I think. Yes, let us read it and I give you time a little bit to think about it. Using the digits 1, 2, 3, 4, and 5, how many 7-digit numbers can be formed that each number contains exactly 2 distinct digits? Yes? I want you to think a little bit about it and then we work it out together on the board. Okay, could you somehow come up with some idea here?
Is the problem clear? Of course, it is clear that you have to have repetition, yes? Because you are supposed to use only 5 digits, but your goal is to make a 7-digit number. So definitely we have to have repetitions, but we can have, we want to do it in a way that you can see exactly 2 distinct digits. For example, this one is one of the acceptable ones. 1, 1, 2, 2, 1, 2, 1. 1, 2, 3, 4, 5, 6, 7. This is acceptable because I have used only the digits that I'm allowed to use, and then I have only 2 distinct digits. But for example, 1, 1, 2, 3, 3, 2, 3, 1, 2, 3, 4, 5, 6, 7. This is not acceptable. Even though I am using the same digits, but I have more than 2 distinct digits. 1, 2, and 3. So this is not acceptable. This is acceptable. So I want to count all possible ways that I can construct acceptable 7-digit numbers here. So what is your strategy? Yes.
Can you begin using the product, like first stage, second stage?
You can do whatever you want to. If it is reasonable, you will get the points, yes? So what should we do? What is your strategy?
I thought maybe that you begin with the first number and the amount of options you have to choose for it.
Okay, but you have to make sure that this is going to work. So you are free to choose any strategy that you want, but that is up to you then to complete your task. Yes? That's why I'm saying that usually in combinatorics, think how your brains, because I was completely sure that you can write such a number, yes? Okay? So you need to ask yourself, how was it the case that my brain knew how to write a number which is acceptable? Yes?
You start by choosing the two numbers.
Yes, because you are supposed to have two distinct digits. To be honest, when I started writing that number, I already decided about 1 and 2 to put them there. So that's why I'm saying, if you think how your brain does that, you probably know your strategy. So yes, I also agree with you. I have 5 options, I have 5 digits, I want to choose 2 of them. So these are the numbers that I want to put them in my number. Yes? So I have how many options? 5 digits are presented, and I want 2 of them. So far, what I have done nothing except choosing my number. So it means that 1, 2, 3, 4, 5 is on my list. I took my marker, I put a mark on it and a mark on it. So this means I chose these numbers to be inside my number. Okay? And then what should I do? But then the problem is a little bit complicated. If it depends how you want to look at it, yes? Because when I say I want to use 1 and I want to use 2, but I didn't tell you how many 1s I want to use, how many 2s I want to use. Yes? Might be you write 1, 1, 1, 1, 1, 1, and then 2. This is acceptable. Okay? Because I have 6 1s and 1, 2. But even this one can be written in a lot of ways, yes? 1, 2, 3, 4, 5, 6, and this one. So this should be counted once, this should be counted another time. But the problem is still not finished because, for example, I can have 4 1s and 3 2s. That's also acceptable. But then I will also, that is why, if you think in this way, it seems that you have to consider a lot of cases and then add them up. Is that understandable? Whenever, this is my advice to you, whenever you see that you have a lot of different scenarios that you have to add up, instead of thinking in this way, think in the complement way. Okay? Think in a way that, okay, let us count the number of items that I don't like. If I can understand the total number of items, I take it off. What is left for me is the total number of things that I want. So why this comes to my mind? Because I see that there are a lot of things that I have to consider. If I want to do the sum rule, I have to consider this case that I have 1, 2, and 6 1s and count all of them. Then I have to consider the cases that I have 2 2s and 5 1s. I have to consider a lot of scenarios. So whenever this comes, it is usually better to think if the complement principle is simpler. Okay? But anyway, I'm waiting for you to tell me what to do next. Yes.
I didn't do the complement way,
Mm-hmm.
but I made it a little shorter instead of counting all the ways because of the rule you said before. So
Yeah.
choose one, it's the same. You could just multiply by 2 when you come halfway. So there's 6 different ways that you can, like you said, you can either have one of the first number and then 6 of the second one and so on.
Mm-hmm.
So I chose, for the first variation, there's 7 different ways, and how I came up with that is you do 7, choose 1.
Mm-hmm.
So you choose the spot for the first one, and then 7, choose 2, and 7, choose 3. And then you can multiply by 2 because the other way is the same way.
So what is your final answer?
126.
100, yes. So in total, your answer is 1260.
Yes.
That's correct. But you actually tortured yourself a little bit. Because that is correct. So if you write that in the exam, of course I will give you the points because that's the correct logic. But look, that is a much simpler way to do it. Instead of, I can consider only one scenario and the problem is finished. If you use the complement rule. So what I have done so far, I have made my mind about 2 digits. For simplicity, let us consider I have chosen to use 1 and 2. Okay, I want to write a 7-digit number. 1, 2, 3, 4, 5, 6. Okay? And how many digits are available? 2. So how many options I have here? 2. Either I put 1 or 2. How many options are available here? 2, 2, 2, 2, 2. Okay? But is it all or something I am missing here? Something I am missing. How many cases I have made wrong here? Yes?
There's two cases where it's all of the same number.
Yes. Because when I say I have 2 options here, it means that I can choose 1 or 2. I have 2 options here, it means that I can choose 1 or 2. And up to the end. One of the cases is that I choose 1, 1, 1, 1, 1, 1 here. Is this number acceptable? No, because there are no 2 distinct digits. There is another one that is not acceptable. That is 2, 2, 2 until the end. So except these 2 cases, everything left is acceptable. Yes? So how many numbers are there in total? 2 to power 7. But 2 of them are not accepted. That's it. So you just multiply it by 2 to power 7 minus 2. Yes? So then this number is the famous number is 10. This number, I have it in my memory, 128 minus 2 is 126. So that is the answer. You did the correct thing, but I think you considered more cases. Yes? But that is working. But at least it shows that you are completely understanding the problem because you came up with the correct answer. But this one is a little bit faster to think about. Is that clear? You see, the problem is not hard. When I describe it, when you want to solve it, you say that, oh God, how many cases I have to consider? Okay? But especially, sometimes it is inevitable. We have to consider a lot of different scenarios to add them up. But sometimes if you're smarter, you can find a faster way. The point is that, do you understand my logic now? So what I have done, this one takes care about the numbers I choose. One of them is, for example, decide to choose 1 and 2. So this means that I already made my mind. I want to use 1 and 2. But I have to write a 7-digit number with those numbers. How many options are available? It's like a binary code. I have 1 and 2. So I want 2 options here, 2 options here, up to. But if I consider all cases acceptable, I am considering only 2 cases which in principle shouldn't be acceptable. The ones that is 1 from the beginning to the end. This means that I have 1 digit used, but I'm supposed to use 2 distinct digits. That is not acceptable. The other scenario that I use all 2's is not acceptable. So the whole combination is 2 to power 7. It is like a binary code with 7 places. So it is 2 to the power of 7 minus 2. So I multiply. Is that right? So I would consider this also a good problem, yes? Make yourself ready for the exam. I will try to make these kinds of questions, okay? No, I'm kidding, but this is you shouldn't be worried about the exam. You need to be worried about learning. So here, this answer will be this number. Any questions? Let us go to the next one. These questions are simple, yes? There is nothing that you need to be worried about. You just need to work it out and solve it. So it has nothing to do with counting. I would say that these problems that you also receive in the exam will be simpler if you are good in algebra. Yes? So here we want to see if for the natural number n this relation holds. We want to find n and type it here. Okay? So you can work it out so that I have time to clean the board. Okay, so let us do the problem together. This is very simple. So I have to write p n and 4 plus, what is it, c n and 4 is equal to 25 c n and 5. We want to find n. Yes? Very simple. So what should I do? I have to write a formula for it. So this becomes n factorial, the difference between these numbers factorial in the denominator. This one n factorial, the difference between them factorial in the denominator, but I have also a factor of 4 factorial in the denominator. This is combination, this is permutation. On the right hand side, I will have the same. Yes, is that right? And then I start simplifying things. For example, my goal is to get rid of the denominators. I don't know how do you do it, but I prefer to get rid of the denominators. So I have to find the LCD between the denominators. So n minus 4 factorial can be viewed as n minus 4 times the previous number. What is the number previous to this? You have to subtract 1 unit from this. It becomes n minus 5 factorial. So n minus 4 factorial can be written as n minus 4 times the previous number factorial. Yes? And the same true for 5 factorial. So 5 factorial is what? Is 5 times the previous number factorial, 4 factorial. So you don't need to write it down, you need to think it this way. Okay? So what I will do, so let me write it down. Okay, so n factorial, instead of n minus 4, I write that. N factorial instead of 4 factorial. These two are this one I copy and paste, but this one I write n minus 5, n minus 4 times n minus 5 factorial. On the right hand side, I will have 25 times n factorial. Instead of 5 factorial, I write 5 times 4 factorial and copy and paste that one. Yes? Now, what should I multiply? I want to multiply something on this side and that side so that all the denominators are vanished. So, I have to multiply by 5 because of that 5. I have to multiply by 4 factorial because of this one and that one. I have to multiply by n minus 5 factorial. Let me write, I have to multiply by n minus 4 factorial because of this one and that one. I have to multiply by n minus 5 factorial because of this one, and that one. Yes? I want to get rid of all the denominators, but I don't, of course you can multiply by this, by that, and that. This is a huge expression, I don't want to do that. I want to do it in an optimal way. So if I multiply this by this, what will happen? This and that are cancelled, this is left. But this is 5 factorial. So 5 factorial will be multiplied there. Plus. If I multiply this here, 4 factorial, cancel this one. These two will cancel these two, 5 is left. So 5 will be multiplied here. On the right hand side, if I multiply this there, n minus 5 factorial will cancel that. 4 factorial and 5 will cancel this. So n minus 4 is left. I have 25, n minus 4, and then n factorial. Yes? This is what I get. But then I see that n factorial repeats itself as a factor here, as a factor here, as a factor there. I divide everything by n factorial. If I divide this by n factorial, 5 factorial is left. I divide this, 5 is left. I divide that, and this is a very simple calculation. Of course, 5 factorial, you have to do it 1 times, 2 times, up to 4, up to 5. It is 120. It's 125. I divide everything by 25. This becomes 5 times. And then I move it to the other side, so n becomes 9. I'm not saying this is the only way, but I think this is the optimal way. So if you are dealing with an equation with fractions, the best thing to do is to get rid of all fractions by multiplying by the LCD, least common denominator of all the fractions. Understandable? This is, I would say that these kinds of questions, at least they are straightforward. We know what we are supposed to do. The next question is also of this nature, if I remember it correctly. Let R and N be natural numbers with these properties, and we know that this one is A times this one. What is A? You want to calculate A and see which one of these options is the correct answer for A. Okay, so let me write it here on the board. I want to
give you another way of doing this later after everything is settled down. So what is your suggestion for me? The point is that what A is. How can I calculate A? A is your unknown. Okay? If you want to find A, do you agree that I can do that? I can divide this by that. This is your A. And it is reasonable because A is expressed in terms of N and R. And if you look at the options, all options are in terms of N and R. But not in that form that you see on the board now, in a simplified form. So this means that you just need to simplify this. Okay? So how can I simplify this by the formula? N factorial on top, R minus 1 factorial. The difference between them, N minus R minus 1, which is N minus R plus 1. So it becomes N minus R plus 1 factorial. That is what I put for the numerator. I put something similar for the denominator. So this becomes N factorial. This is R minus 2 factorial. The difference between them, which is N minus R plus 2. Yes? And then I have to simplify. For example, this N factorial and that N factorial are simplified. And then you know that this is 1, this is 1. This goes to the numerator, this goes to the denominator, yes? If you have A over B divided by C over D, you can write it as A times D divided by B times C. So this will be multiplied by 1 divided by, this also will be multiplied by 1. But there are factorials left. I want to simplify it more. So how can I simplify it more? Yes? I copy and paste R minus 2 factorial. But instead of N minus R plus 2 factorial, I write N minus R plus 2, but multiplied by the previous factorial. What do I mean by previous number? I mean 1 unit less. So it becomes N minus R plus 1 factorial. And in the denominator, I will do something similar for this one. I write it as R minus 1 multiplied by the previous number factorial. The previous number becomes R minus 2 factorial. And I copy and paste the second term. Yes? And what happens? You see that this one and that one are gone. This one and that one are gone. So what is left for me is just simply yes, I hope that I have it in one of the options or not. Yes, it is which option? First option. Yes, is that right? So these two problems are not related to counting. But what I want to mention, might be this is good. This is so the homework is finished here. But what we realized that n r minus 1, what did I found for A is n minus r plus 2 divided by r minus 1, n r minus 2. Okay? This is what I got. Because I was able to calculate A, if I put it back, I will get this one. And if you don't mind, let me switch r to r plus 1 everywhere. Because this is an identity, it will be valid if I choose r plus 1 for r. So what happens here, it becomes this number becomes r, this number becomes what? If I replace r with r plus 1, so it becomes n minus r minus 1 plus 2, so it becomes n minus r plus 1. Okay, so this is the relation that you have. Okay, if you ask me how did I know that,
I would say that I did this problem, I found A, so this is the identity I got. I want to write it a little bit more reasonable. So I switched R to R plus 1 everywhere and I got this. Yes? Now the reason I brought this up, because now I want you to see we can prove this by storytelling, which is not trivial at all. So we want to come up with a story, yes, so that the answer to that story somehow proves this identity. Okay. Because there is no time, let me just do it for you because I want to finish everything. By the way, the new homework is about binomial expansion. So try to do that for the next time. So what I will do, I will multiply that by R. And I ask myself, because do you agree that if I can answer this question mark, if I believe that this question mark is true, then this means the same thing. So instead of a story telling that one, I give a story that the answer is this. Okay, so let us give the story. Okay, so let us say that I have n students, students 1 is 2 up to Sn. I want to choose all of these students and make one of them the boss. This is my story. Okay, can you tell me how many ways I can do that? I have n students. I want to choose all of them and give the role of being boss to one of them. In how many ways I can do that? Yes?
And choose R,
N choose R,
and then
multiply,
by R choose 1.
R choose. R choose 1 is what?
The, when you choose the boss.
Okay, what is this one at the end?
R.
R. So yes, your story is good, yes? Because this gives me the left-hand side of the story. So this story, if I want to count the number of ways that I can accomplish my story, at least on one side it is obvious. Okay? Is that clear? But why this story can also be viewed in this way? Because if I can't do that, then it means I have my proof without any analytic work. Why do you think? So one way of thinking to set up this story is what Umar mentioned, and we came up to the left-hand side of the story. So if you look at it in a little bit different way, in a wise way, that you can reach up to the right-hand side for the same story, they have to be the same. What is the story? What is the way to look at the same story from this perspective? From that perspective, sorry. How can you come up with the same story from a different angle? So this time, this is the answer.
Can say maybe that you have n people.
The same n people.
Yes.
Okay, the strategy is the same. So now, yes, what I do?
You take away all amount of people from them.
R means that you have still R. But look, what you are supposed to have?
R minus 1.
R minus 1. So you have to somehow cook up your story in a way that R minus 1 is involved. It is very easy, think about it. So still the problem is the same. What is the problem? R students, 1 boss. The way that you did it is more or less the natural for human brain. We choose the R people, and among from those R people, I choose 1, which is the boss. This is the human way of doing things. But a little bit robotic way of doing things might be, yes?
You choose the ones that are not the boss.
Okay, so it means that I choose R minus 1, because how many people I have to choose? R, one of them is the boss. Okay, what I do, I choose R minus 1 people from my students. I know they are not supposed to be the boss. Okay? And then from the leftover people, I choose the boss. How many people are left now? N people were in total. R minus of 1 of them are chosen. So how many of them are left? Okay? Now, from these people, I want to choose my boss. So it means that from these people, I have to choose one of them. Which is what? N minus R plus 1. So that is the same story, looked from two different perspectives. So these two numbers should be the same. Yes, is that correct? So this is an extremely powerful trick in combinatorics. Of course, this was not hard because I could do it analytically without even thinking, just doing the algebra. But sometimes the problems are hard, so then they come up with a very strange, nice story, and everyone are convinced. Like, are you convinced that this is the same problem? Here I choose our people are in front of me, I choose one of them as the boss. But what I can do, I can choose R minus 1 people first, and then say that wait here, I want to go back and choose your boss. Okay? That will be the same thing. At the end, I will have 10 R students with one boss, in either way. Yes? So, this is also good to know. Thank you very much.